Okay, so we're first going to just get into a couple little rules, and then we're going to start working with derivatives. And even though you're still expected to know how to do limits, derivatives are the result of limits that you may be able to find a shortcut. But not only, and if I have time today, depending on where we end up, I'm going to show you how you can use derivatives to solve some very difficult limit questions. Because you still on an exam, on a final exam, I may ask you to calculate the limit of this. You still have to know how to do limits. But you can use a little bit of derivatives in your limits to even make life a lot easier. Now, the first thing we're going to talk about, now I always want you to remember that what we're talking about is slope. Derivatives is slope, okay? Now, if we have any constant function, okay, so example, let's just say y equaled 3. Now, if you were to graph this, right, here's y equals 3. Very complicated graph. What would you expect the slope to be? 0. Okay? So, if you take the derivative of any constant, it should equal 0. Okay? And I think that makes sense because the slope is 0. So it's d over dx. That's the derivative at x. And it's kind of confusing because there's no x in it, but you can assume that there was a 0x somewhere that canceled it out. Okay, so I guess I could have showed you on here. If this is the constant, right? Just by looking at that, if I took the derivative of it, I should get 0 because the slope of anything that is going in a straight line horizontally will give you 0. Okay? Now, if you take the derivative at y equals x, okay? So my y equals x would look like this. What would the slope be of y equals x? 1. Yeah, because it's, this is like 2, 2, 3, 3, right? These points. So rise over run would give you a slope of 1. So I'm just going to put up here m would equal 0 here, m equals 1. So the slope is 1. Okay, so whenever you have y equals x, the slope will be 1. Okay, now this goes for all other variables. So it doesn't matter what the variable is. If you're just taking u, it's going to be 1. If it's z, it's 1. It's t, it's 1. Okay? Now, I could prove this doing a limit because of time. I'm not going to go through it because proofs aren't part of the curriculum, even though you will be doing them in university. Now, if you were to take the derivative of x to the n, the derivative equals n x to the n minus 1. Okay, so if you had y equals x to the n, then y prime would equal x, or n, x to the n minus 1. So, if y equals x, now remember there's a little 1 up here, right? Y, or the derivative, would equal 1x to the 0, which equals 1. So all you ever have to do, well, let's just do a couple more examples. You'll see what we have to do. So if I had y equals x squared, that would y prime would equal 2x to the 1, which equals 2x. Y equals x cubed, your derivative will equal 3x squared. Okay, now let's go on to example 1, because what if I had y equals 3x squared? Okay, I can hear people saying it out there. So what I always do, this is how I do it, I take this number, the exponent, and I multiply to this number, and then I take 1 off that exponent. Derivatives are really easy. Okay, compared to limits, they're not even in the same category. So y prime would equal 6x to the 1, or 6x. Okay, now if we had time, I would put this in the entire limit formula. We take about 6 lines, and you would see we would come up with 6x. Okay, I want to keep doing just a couple more examples. So example 2, we have lots of room here. What would x to the 6? If y equaled x to the 6, y prime would equal 6x to the 5. That's supposed to be a little prime. What's wrong? Okay. Let's keep on doing a couple more examples. Example, I'm going to make them a little harder. Example 3, y equals square root x. So first of all, rewrite that as an exponent. So y prime would equal to the negative 1/2, which would equal 1 over 2 root x. Okay, now just one more, just to kind of solidify this a bit. What if I had y equals x to the negative 2, or 1 over x squared? The derivative would be y equals negative 2x to the negative 3. Okay, so what am I doing? I'm bringing the exponent down, and I'm always taking 1 away from the exponent. Now later you're going to be doing antiderivatives or integrals, and that's given this coming up with this. So it really messes with your head after a while, because you get good at this, and then you need to go backwards. Okay? So I almost want you to start thinking about that. Would you know a strategy of how to be able to take this and go here? Or maybe we should even look at a simpler one. If I had y equals 2x cubed, y prime would equal 6x squared. What would be a good way to get back to y? What would be a strategy? Well, what is my new exponent going to be? So you're going to, but where'd you divide by 3? So this is going to be 3, isn't it? Right? So then I would, right. Okay? But that's actually not correct, because you'd have to put plus c. And the reason why you would have to put plus c, because what if this was the original? What if it was 2x cubed plus 3? That would still give me 6x squared as a derivative. Okay? So when you do the antiderivative, you got to come back and you always have to put plus c. Does everybody understand that that is the derivative of that one? So if I said give me the antiderivative, you're always going to have to put plus c. because there might have been a constant there. Because every time you do a derivative of a constant, it goes away. So if you do the antiderivative, you got to bring it back. You wouldn't know what it was, so that's why you put C. Okay? So that's just kind of looking into the future, because it's like every single question you do of these, it actually makes integrals harder because you get so good at derivatives. But don't worry, that's a long ways away. Okay, so let's just go quick. Let's do some examples. What would be f prime of x, or the derivative would be what? There you go. How about number 2? F prime of x. Negative 3 times 5. Negative 15. X to the negative 4. Okay? Which, just so we are always on this could be negative 15 over x to the 4, right? Okay, at which point on the curve y equals 3x squared is the slope of the tangent equal 24? Okay, well, we have to be able to get, so it's the slope formula, so we can find out what x has to be 24. Okay, so find the slope. Slope formula would be what? (6x). Okay, so 6x now, well, y prime stands for the slope, right? The derivative is a slope, so then 24 equals 6x, divide by 6, divide by 6. X equals 4. But it said at what point? 4 is not a point. 4 is the x, right? How am I going to figure out the point? Plug it always back into the original to get the y value. So y would equal 3 times 4 squared. That's 16 times 3, which is 48. So at what point? 4 comma 48. Now, if you look at derivatives, they are the same thing as limits, so they follow the same rules. If you have a constant in front of a derivative, you can put the constant out front. So you can take this c and put it over here. So you could rewrite this as c and then do the derivative of f of x. So the whole time that we were doing example 6x squared, it says y equals 6x squared. You can, put the 6 out front and just do the derivative of the inside, which would be 2x to the 1. And then that gives us 12x. So really, this is what you're doing the derivative on. Okay, the 6 is just hanging around to get multiplied by it. I always do it in one step, but it is something that can help you later when you're trying to actually do some questions. Now, when you have, it says, find the derivative of f of x plus g of x. Well, that's the same thing as finding the derivative of f of x plus or minus the derivative of, I should have an x there, g of x. And derivatives obey the limit laws. Okay. So we can go quickly through number 1. Y prime would equal 8x cubed minus 7. Now see how the 5 is gone? right? Because the slope of 5 is 0. So you see later when we have to find the antiderivative and we got to come backwards, we're going to have to put plus constant there. Even though you may not know what it is, you still have to say that there might have been a constant there. And the constant could be 0, so then it's not really changing if it was just 2x to the 4. Okay, f of x, I would recommend first always changing it to exponents. 1/3 plus x to the 1/4. Okay, it's always fun remembering how to subtract 1 from fractions. So the easy part is bringing it down. 1/2, that would be x to the -1/2. So you're going to be subtracting 2/2 there. Now here you're subtracting 1 from 1/3, right? So 1/3 minus 3/3 is -2/3. And 1/4 minus 1 is minus 4/4, -3/4. Okay. Now, if they ever give you radical signs in the question, it's usual to put it in the answer. Okay. So this would be 1/2 root x plus 1/3. Okay, remember, top goes on the inside. 2/3 plus 1/4, or sorry, 1/4 root. Top goes on the inside. Oops, top goes on the inside. Okay. Now h is not really a big stretch, but I'm going to show you actually today how to do h just the way it is. But right now you can't do h just the way it is. You have to FOIL it out. So this would be h of t equals 6t squared minus 3t plus 4t is plus 1t minus 2. So if we take the derivative of that, h prime of t would equal 12t plus 1. Okay, at what points on a curve would this line have a horizontal tangent? Recall this occurs when the slope equals 0. So we're looking for what would be the max and mins of this graph. Now remember when we did, when you do pre-calc, the only way you can find max and mins algebraically is by completing the square. That's the only way algebraically. So you'll find out that derivatives are really nice to be able to help you find max and mins with a lot less effort. Okay, so y prime equals, let's do this right from the question. What would it be? 3x squared plus 6x minus 24. And since we want to find where this is a max or a min, we're going to set it to 0. Okay, we want to factor. And because of lack of time, I'm just going to help you out here. We first want to take out a 3. Leave me with x squared plus 2x minus 8. Looking for two things that add to -2 and multiply -8. You got 3 times x plus 4, x minus 2. So when does this equal 0? At x equals -4 and 2. Now it didn't ask for the x values, it asked for the points. So whenever you have to find points, make sure you go back into the original. Okay, so we're just going to go y equals negative 4 cubed plus 3 times negative 4 squared minus 24 times negative 4 plus 1. And that will give you 81. Okay, so we got negative 481 is 1 point. At this point, I would say, hey, that's probably a maximum, right? Because 81 is a pretty high y value. Let's try the other one. Y equals 2 cubed plus 3 times 2 squared minus 24 times 2 plus 1. Actually, this is a cube function, so we don't know for sure if it's got a maximum in there. I have to do a couple more tests. So you will get negative 27. So 2 negative 27. Again, looks like a min, but I'd have to test some other things. Okay, so those are my 2 points. Okay, this one here says for this function, okay, at f of negative 1, it has a slope of negative 6. Find a. So this isn't that big a stretch. First of all, we want to find out our derivative so we can make it equal negative 6. So f prime of this would equal, what would it be? 6x squared minus 10x plus a. And it says the slope equals negative 6 at negative 1. So it should equal negative 6 when I put in 6 times negative 1 squared minus 10 times negative 1 plus a. That's negative 6 equals 6 plus 10 plus a. I'll minus 16 to both sides. I'll get minus 22 equals a. Okay. Now this function here, it is almost, or this question is almost the same as the one before, except I have 2 unknowns. And when you have 2 unknowns, all you have to do is use elimination or substitution, and you can solve for, you can get rid of one of them, leaving the other one behind. So we first know that when you take the derivative of this, that at 1 the slope is 15, and at negative 1 the slope is 23. Therefore, what must the equation be? Well, if I take this and make a derivative, f prime x would equal 4x cubed plus 3ax squared plus 2bx minus 2. Okay, so I'm going kind of quick because I got 2 lessons to do today, but hopefully you're working with me here. It's 15 when I put 1 in, so 4 times 1 cubed plus 3a times 1 squared plus 2b times 1 minus 2. (15 equals 4 plus 3a plus 2b minus 2. If you bring everything over to the left side, you'll get 13 equals 3a plus 2b. Okay, that's one equation. Second equation happens when I put negative 1 in. So f prime of x equals, I'm not going to write it again. Let's just go 23 equals 4 times negative 1 cubed plus 3a times negative 1 squared plus 2b times 1, negative 1, sorry, minus 2. 23 will equal negative 4 plus 3a minus 2b minus 2. Get it all on the left. 29 equals 3a minus 2b. Okay, I should remember this from grade 11 and 12. When you have two variables, two unknowns, you can either put them over each other and you can add them together, you can subtract them. You might have to multiply one of them by 2 to get rid of the variables. This one's pretty nice. 13 equals 3a plus 2b. 29 equals 3a minus 2b. Okay, this is called elimination. Okay, and the way that this one works is I would add them because my 2b's will go away if I add them. So then I would get 42 equals 6a divided by 6, 7 equals a. Now you take your 7 and put it back into either one of them. I'll put it into the first. So I'm up here. 13 equals 3 times 7 plus 2b. Okay, minus 21 to each side. I'll get negative 8 equals 2b. Negative 4 equals b. Okay, now there's something I'm going to show you now that this isn't really part of the curriculum. If you were in AP, it would be. But it's actually one of these add-ons that may make your life easier. Now it's called L'Hôpital's rule. It's like hospitals, but without the S. L'Hôpital's rule. It actually is quite, like, I don't know how these guys figure this stuff out, but in the last unit, we were doing a limit like this. I want to give you an example. Limit x goes to negative 2 of 2x squared plus 7x plus 6 all over 3x squared plus 7x plus 2. Now, if you put negative 2 in, you do get 0 over 0. So it is indeterminate. So what do you do when it's indeterminate? Simplify. So we'd have to factor the top, factor the bottom. Okay? And that's, you're into some work, right? Because you're looking for what two numbers add to 7, multiply to give you 8. Then you're going to have to split it up, right? So I'm going to take away from the fun experience and I'm going to show you what it looks like factored. Okay, and that is x plus 2 times 2x plus 3 over x plus 2 times 3x plus 1. Now it's a little bit of work at getting there. I made it look pretty simple, right? It looks like, oh, one step, easy. Why do we need another rule? Okay, but it takes a long time to get there. That's probably 3-4 minutes on a math test to get this done right to here. And then you're like, hey, cool, this cancels, good, right? That's what we wanted, because if I put negative 2 in there, it was bad. Now if you put in, now all you do is substitute, so you'd go 2 times negative 2 plus 3, and 3 times negative 2 plus 1. So that's negative 4 plus 3 is 1, or negative 1, over Negative 6 plus 1 is negative 5. This equals 1/5. Okay, so that's a lot longer question than I, did here because I factored it for you. But now you can use this rule here. So if you have limit of x goes to negative 2 of 2x squared plus 7x plus 6 all over 3x squared plus 7x plus 2. So you go limit of x goes to negative 2. I'll let everyone, so we're just writing down the question. We haven't done any work. Now, let's do the derivative of the top. What would it be? 4x plus 7 on the bottom. 6x plus 7. Now, we're going to put in our negative 2. Four times negative 2 plus 7 is negative 1. 6 times negative 2 is a negative 12, plus 7 is negative 5. You get 1/5. Okay, so that is fast. Okay. So it's kind of a little weapon now you can use even on your final. I know it's the limits, and all of you guys have written the limits test, so too bad for you. You can't get it back and change anything. But it's pretty sweet because no more factoring. And how guys come up with this stuff, I don't know, but it works every time. When it's indeterminate, right? That's not